Alright, welcome back. Let's get going on this Go game. Now it's time to make black stones and white stones. So, don't right click on actor, right click on stone, and select new subclass. And you should have all of your stuff that we put in there, right? So I am going to select this BlackStone image, and I call this name of this class BlackStone. All right, and there we have it. And you would read this: Blackstone extends stone, which extends actor. So Blackstone is a stone, which is an actor. So what do we need to do for our Blackstone class? Well, we've already written a very good act method in stone that we inherit. I don't need to rewrite act. There is no reason for me to override it. And this is important that we delete this, because if we didn't, what would happen here is it would run this act method instead of the stones, which means it wouldn't do what it's supposed to do. All right, so we're just going to do that instead. Now, what about constructor? Well, I don't really need a constructor. Again, everything was taken care of for me in Stone's constructor. So the only thing I really need to have is that black stone shape be assigned to it. I've already got all these good methods, except for the fact that, remember, check liberty is broken. But look at the power of subclassing. I would have to redo this for both the Blackstone and the Whitestone, all of this, but I don't. I just have to write check liberty. Public Boolean check liberty, and checking liberty is different whether you're a Blackstone or a Whitestone, because you just the way that it works. So we're going to override it. At this point now, when you try and run the act method, when this act method is called on a stone, if that stone is a black stone, it will no longer run this one. It will run this one. Okay? So before we get too far in this, let's go over this algorithm. This is an advanced algorithm. It is a searching algorithm. It is the same algorithm that we use to write code to get out of a maze. It's the same algorithm that we use a lot in different data structures, so it's super important. It is a search algorithm. So let's get to it. The way that we're going to do this is we're going to use two different lists. So I've got a situation here on this Go board, and let's say that white has just played this stone right here. Now, if you look at the board and you remember our rules for Go, can you determine whether or not these black stones have been captured as a group? Well, the answer is no. They have not been captured because there is still one vacant liberty that they are adjacent to. Remember, they have to be up, down, left, right. So this stone here that we just got lost its liberty is still okay because it's connected all the way back to here. So what we're going to do is we're going to write code to start from a stone in the group and search out for a liberty. And if it doesn't find one, we're going to mark it for removal. If it does find one, we won't. Well, actually, we already wrote that part in the act. We're just going to return true if it has a liberty. So in order to do this, we need two different lists. There'll be java.util lists of type ArrayList. So the list in Java is actually what we call abstract. More on that later. It means you can't actually make an instance of it. You have to use something that, like a subclass. It's a little bit different because it's an interface, but that doesn't matter. So the concrete version of list is called ArrayList. So we're going to make an array list here. And we're going to have two of them. One of them I think we'll call stones to check. Okay, and so this is just going to be a listing of stones that we need to check. And over here, we're going to have stones that have already been checked. And that's important too, so that we make sure that we don't check the same stone more than once. All right, so let's say that we are starting at I'll use letters. Let's say we start here at this A. This is the stone this is a stone that has been called on, right? That we are calling the check liberty on. So what we're going to do is we're going to add this to the stones to check list, and it's actually going to be we're going to be adding it as this. Okay, and just So once again, we'll be looking at an instance of this. Or in this case, it's going to be what I'm calling stone A. We won't actually know any of these stones' names, but I'm just going to, helps me talk about it. Okay, so we're going to add that to the list, and then we're going to enter a loop. And our while loop is going to be while this list is not empty. So while it's not empty, we're going to keep doing this over and over and over again. Step 1, take a stone off the stones to check list. Okay, so that's the first step. Well, we only have one in our list right now. And put it on the stones to check. Stones checked, meaning we've already checked them. And this is how we check them. Actually, I guess we would take them off of this, then we check them, then we add them. But I just wanted to slide it over there right quick. So we check this stone. Does it have a liberty? Well, we need to look at its offset of 0, -1, 1, 0, 0, 1, -1, 0. And none of those are open, are they? They are all occupied by a stone. Because we checked it, but then what we do is we add stones to the list to check. Because A is connected to this stone, which I'm going to call B, because it's connected to it, I need to add it to the list, because if B has a liberty, then we're okay. A didn't, but B might. So I'm going to add stones to check B. Now, I go back on my loop. It says, while not empty. Well, what do? We're going to take off an item from the list, and we're going to check it. So I'm going to check B next. So from B, I look and I see there are no liberties, so I need to add stones if I'm connected to black stones. First, I see A, but A has already been checked because it's in my list, so I don't want to use that one. But I can add C, so I'm going to add C. Then I'm done. I've done the steps. I took a stone off my list. I checked to see if it had a liberty. If it didn't, so I add all the stones it's adjacent to that aren't on my already checked list. I'm going to do the same thing with C. C gets, let me go ahead and just start labeling these all, actually. So I'll call it D, E, F, G, H. And we'll call this I and J. So C is going to get checked next. And C does not have any liberties, but what can we add? We'll check. We'll see that there's a stone B and a stone D, but B is in our list of stones that have already been checked, so we only add D. Then we'll take D and we'll do the same thing. D gets checked. There is no liberty, but there is a stone E that is connected to that has not been checked yet. So I'll put E there. All right. Then I'll take E and I'll check it, because once again we're still. Remember, while the list is not empty. So E is connected to two different stones. So I'm going to add both of those to the list. So I'm going to add F and I. So now we still keep going because it says while not empty. There's actually two in this list now, and it turns out like if this was a black stone here, we might have 1, 2, 3. We'll oftentimes have several stones in our list. So I and F. Now at this point we actually need to pick. Are we going to always remove stones now that we have two of them? Should we remove from the top of the list or the bottom? Well, it actually turns out you get a different shape of your search depending on how you do it. And that actually has different benefits from finding maybe all the exits to a maze or finding the nearest exit to a maze. So they have different ramifications. For us, it doesn't really matter. So I'm just going to take off from the front, which is index 0. And so I'll take off the F. And I'm going to add all the stones that F is connected to. Well, actually, first I'm going to check, is F got a liberty? It doesn't, but it is connected to G, so I need to add G to my list of stones to check. So I'm going to add G right there. Now that I've got G on my list, I check G. No, I don't, because we were pulling from I, so I got to check I. So I'm going to come over here now. Now, is I connected to a liberty? It is not, but it is connected to stone J. So I'll add J, and J is going to come down here. So when you remove from a list, everything slides up. So now G is now at the top of my list, and I is now down here. Okay, and then we're going to pull off G, and G, guess what G has? A liberty. And so at this point, we're actually not ever going to finish this condition here because we're never going to be empty, but we're just going to return right there, breaking the loop, breaking the method, saying, return true, I found a liberty. Okay, so that's what's going to happen you have when you have a liberty and you have to search all of them. But what would we do if we had a stone there? Okay, well, I'm trying to make that white. Hey. Like that. Ah, good. And then I want to fill it. All right, well, this is painstaking. All right, can you buy me that's a white stone? All right, so it's a white stone now. All right, so what would have happened though if this were the situation? Well, when we pulled G off of the list, we would have not found this liberty here, and instead we would have added an H. Then we would pull off an I from the list, which I already have over there. I'm not sure why. I would pull a. Oh yes, I would. Yes, I would pull an I off the list. Not sure why I already have it over here, but I guess I messed up. So I'm going to pull an I off the list and move it over here while I check what it's connected to. So I is going to allow me to get a J. So H goes to the front of the list, and J becomes my new member. Now I'm going to check H. Well, when I check H this time, there is no liberty, and there's no stone that has not already been checked. So H is going to move over here, right? I definitely no longer. It's going to add to this list, but it's not going to add anything. So then I check J, and J will go over here, but again, when I check J, there's no stone that J is connected to. It's not connected to a liberty, and there's no stone that I haven't checked. So at this point, actually, my stones to check list is empty. And that's when we exit the while loop and return false. So that's it. That's the search algorithm. Simple, right? Hey, it's very common, though. It's very important. And, the more times you see it, the better. The more you'll think, hey, I can use this. Let me just remember. So that was a breadth first search because we searched all around before going deep down. If we had searched A, B, C, D, E, F, G, H before we came back and did I, that'd be what's called a depth first. And that decision is just, are we going to pull stones off the front or the back of our list? All right. All that is done and done. And so let's code it up. Lots of good stuff to talk about in this particular algorithm. So I said we're going to use a list. So I'm going to say import java.util.list. And I'm also going to import java.util.arraylist. We could actually just use ArrayList and not import list, but I'm going to go ahead and do both. Okay, so I'm going to make two different lists. So I'll say list, and I'm going to make them both BlackStones because I want to make sure that I only put BlackStones in this list. And this is going to be stones to check. And this is how you make a list. We've used lists before, but we only got them back from Greenfoot. List is actually what we call abstract. It doesn't, which we'll talk a little bit more about in a little while, but it doesn't allow us to instantiate it. In fact, you could see the error if I do this. It's going to say it's abstract. You're not allowed to make a class of it. It's abstract just means that it is you're not allowed to directly make an object from it. So you have to choose something that makes it concrete. And ArrayList makes it concrete. If that's confusing for you, you can just start thinking of list as array list, and always call it array list. The only problem is when you get a list from Greenfoot, you have to keep it as list. List is very general, so it's not specific. There actually turns out there could be lots of lists. There's array list, there's linked list, there's monitored list. There's all these different kinds of lists, and as long as you type it as list, they all play together nicely. So we'll go ahead and do that. So the type is list, but you have to instantiate with the new operator array list. Now, it used to be back about maybe 5 or 6 years ago, you had to also say the type over here as well as over here. You actually don't anymore, and so we just like to leave it blank. You do still have to put these angle brackets, the alligators, though, when you make a list. So I know that's some pretty weird syntax. I wish it was cleaner, but that's just the way it is. All right, let's make another list. This one also of type BlackStone, and that will be stone checked stones. So this is just going to be a list of the stones that we have already checked. Checked stones. And again, I'll make it an array list. Okay. Now, we're going to, as we said, add the stone that we're on right now. We're going to start at one stone, and we're going to walk across these other stones. So back in our drawing, we're starting here at this A, and we're going to start by adding it to the list. And do you remember I said that's this? So we get to use our this keyword. So stones to check. Start by checking yourself. So dot add to add to the list this. And we're going to keep doing this while stones to check still has stones to check. So that means the size of the list, so you get the size like that, is greater than 0. And if we run out of stones to check, we know that there were no liberties, so I'll return false. All right, first thing I need to do is I need to get a stone. So I'll say BlackStone S by saying stones to check dot remove. And we said we wanted to remove from the front. We could do it from the back or the front. I'll just say remove 0. It's going to take that stone right off the front of the list to check. And we know that there are stones because we ask it right here. So there must be some. All right, so what I want to do before I do any kind of stone work is I want to make sure that we add this to our checked stones list. So I'm going to say checked stones dot add s, because if we forget to do that, I mean, really, you would think, okay, I get my stone to check, and then I check it, and then I say, okay, I've checked it, let me add it to my list. But we're going to check it. Well, let's not forget. After doing all this coding, we might forget, and that would make this whole thing not work. So here's what we need to do. We need to check. We need to get a stone, and we need to see if it's null. If it's null, then we got a liberty. Okay. There might be a little bitty thing we need to fix though. So let's start with that though. So first we need to get a stone. We need to get a stone at offset of the stone S that we're working on right now. So the first time we do that, it'll be this stone, the stone that we're checking. But remember, we're going to check this stone, and then we're going to move to another stone, another stone, another stone as we pull from the list. So I'm going to say, let's see here, BlackStone. No, I don't know it's a black stone. Hold on a second. We could be a white stone. So I'm just going to say stone. And let's say, let's check to the left first. So stone left equals s dot get one object at offset. And I'm going to the left. So -1, 0. And it's of stone dot class, right? So if left is null, oh, yes, we can't, remember, this returns an actor, but a stone is an actor, but we'll be sure that it's a stone, so we can go ahead and cast it. You cast something, you force it into a more specific thing by putting in parentheses. It's like if I said get rectangle and I try to put it in a square, I have to say, this is just you telling Java, I know it's a stone, trust me, I know it returns actor, but go ahead and force it into stone, because it'll fit. Well, you got to be careful with casting because it could cause an error in your program. But if you're sure, you can do it. And we need to be able to make it a stone. So we could say right now, if left is equal to null, right? then we know that we can return true. And returning true will break this while loop. Because if we found nothing, if this did not find a stone there, then it must be a liberty. And so we can return true that this stone has liberty, whether it's that first stone we checked on the list or way down. Now, what if it's not null? Well, then we'll say we have to ask the question. We have to make sure that it's a black stone. So I'll say if S left, the left stone, instance of, kind of a weird method, kind of a weird operator in Java. It is not camel case. The O is lowercase. If left instanced of black stone. So we're asking, is this a black stone as opposed to a white stone? And we haven't already checked it. It's not one of the black stones we've checked. So I'll say, and not checked stones dot contains left. So remember our check stones, it's just a listing of stones we've already checked. So we're asking, hey, is this stone already in that list? Because if it is, don't add it again. Don't check it again. Because we're about to add it to our stones to check. So that's it. With one little thing we're going to fix. So basically that's the way this is going to go. We're gonna get a stone at offset. If it's null, then hey, boom, we're good. Return true. If it's not, then we have one of two options. It was either a black stone or a white stone. It wasn't null, so it's got to be a stone. If it's a black stone and we haven't already checked it, add it to our list of stones to check. If we have already checked it, don't. If it's not a black stone, don't add it. Do nothing. Just go on to the next one. Okay, so, but there's an issue. We need to deal with this issue that the board, what if we were on this far left side? Well, when I say get one stone at offset, then I'm going to move to the left outside of the world, or possibly to the right over here into our info bar, or up here in down out of the world. Anytime you say get one object at offset and you go out of the bounds of the world, it automatically says null because you're out of the world, so there must not be an object there, right? So I mean, it's true, it's correct, but we need to be careful about that. Oh, I need to do some more casting. Wait, checked stones. This is also going to give me a casting problem. See, remember we didn't know if it was a black stone or a white stone, but now we're adding it to a list of black stones. But we're sure it's a black stone. How are we sure? Because I just asked, is left an instance of black stone? If it is, well, let's force it. So that's that casting business. We've got to learn that. Looks like a little TIE fighter from Star Wars you put your type into. Okay. All right, so we need to make sure that we had space to the left. So I'm going to say, and, you know what? I'm just going to put this whole thing in an if statement because if we don't have room to the left, we shouldn't even check there. So I'm going to say if s.getX, that's the x location of this stone, and we're checking to the left, is greater than 0. So if it's greater than 0, then we must be, let me go back to my board, we must be like on this line here instead of this line over here. You know, we could be on any one of these vertical lines, we know, but no matter where we are, we'd have a space to the left. So, so that would be fine. And what I'm going to do is just take this, I'm going to cut it and put it inside there. Okay, so now it's, I'm just finished my indenting. I just wanted to go over the basics of the algorithm before I went over that kind of little nuance, if you will. Okay, I have a little bit of an indentation problem. Okay. Is that everything lined up there? There. Okay. That looks good. All right. Well, one more there. All right. Perfect. So we check we have room, and then we do the others. Now I'm just going to do this 3 more times. Okay, and then that's going to be the end of this algorithm. So s dot get x. What if we're on the far right? Well, if we're on the far right, we can't move right. So we want to make sure we're less than the size of the board. Well, that was a static final constant from the Go class. So I say go dot game size. Now, if the game size is 9, the last cell is actually at position 8 because we have 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, I counted wrong. 0, 1, 2, 3, 4, 5, 6, 7, 8. But that is 9 cells. So remember, we start counting at 0. So I have to say less than go.GameSize minus 1. If the game is, a 9 by 9, this column here is everything. Every space here would be 8 in the tile. It'll be tile number 8 for the x coordinate. So I want to make sure I'm at 7. So take that game size minus 1, and you got to be less than that. Okay. So do that, and I'll say then I'm going to call it. Let's get a. Oh, you know what? We should have. We need to get more stones here. Let's get some more stones. So we'll say stone right equals stone s dot get one object at offset. So that would be positive 1 0 stone dot class. Okay, and stone down equals casted as a stone s dot get one object at offset. We'll say 0, 1 stone dot class. And one more stone up. And up would be negative in the y's, remember, because y's count up going down, not like in algebra class. Stone dot class. All right, so we go, this is left, that's right, that's down, and that's up. So we're just going to basically, and I'm going to go ahead and cheat, and just kind of copy and paste. So this is right, and we're adding a right. All right, and then let's do it again. This time we need to check the y values. Let's make sure that if we're checking the stone that was up, we have to have room up. So I'll say greater than 0. And then this is up, and there's like several of them. Up and up. Oh, and right here as well. Ooh, go back and get that one. That's why you don't copy and paste. All right. So right. Up, 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 up. And last one. This time we're looking for space at the bottom, which is the bottom row is the size minus 1, so we got to be less than the go.game size minus 1. Remember, when you call static members, you call it on the name of the class. And this is a public variable. So it's kind of weird to not put methods on some parentheses, but it's just a final constant. So whenever you get a constant from a class, you just say the name of the class dot the constant. If you're in that class, then you just have to say the name of the constant. So for example here, when I say just game size, I could actually say go dot game size, but I don't have to if I'm in the class where I created that constant. So that is pretty much it. Make sure that in every one of these if branches you have 1, 2, 3, 4 the same words. And I actually haven't changed this one at all, have I? Down, 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 and down. Okay. So those are up, 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 Down, down, down. Okay, make sure you check each one of these because it would just be, it will wreak havoc on our code if it doesn't. All right, what I want you to do is I want you to do the same thing for the Whitestone class, but it'll be basically, it'll be exactly the same code except where it says Blackstone, you're going to say Whitestone. So yeah, you could copy and paste, but try and actually write it. See if you can do how much you can do from memory or through puzzling it out, because you know the idea is an important thing that we're searching. Um, and that algorithm of adding stones when we find a new one to check, removing them from our list, checking it, adding them to the check stone list, and adding more stones to check. So really important. So let me just go through this one more time, make sure everybody's got it. Uh, if we don't have a stone there, we return true because we found an empty space. If we do find a stone there, we check if it's a black stone and if we've already checked it. If it is a black stone and we haven't checked it, we add it to our list of stones that we have to check at some other time. If we ever run out of stones to check, we know that we've checked them all. There's no liberties. They need to be captured. Next, we need to work on the white stone. What I want you to do is to write the check liberty for the white stone. It should be very close to the black stone. So see how much you can do with it without just copying. Try and understand the algorithm. It's a complex algorithm. It's one we use a lot in CS4, Computer Science 4, data structures and algorithms. But you know, you can handle it. You got this. So, and it's definitely the hardest part of the whole project. So in our next video, we're finally going to make a board and we're going to start putting some stones down. I look forward to it.